In this video, we'll talk about how we actually do row reduction or elimination to solve system equations using matrices. So the goal here is we want to have a systematic process that will get us to an answer no matter what the system looks like. So I want to have an algorithm that I can always follow that will always get me to the answer. So we're aiming towards a row echelon form here, which means I want leading entries of 1, and leading entries must sort of cascade to the right as you go down the matrix. So what do I do for this process? So step 1 is always make sure that you have a non-zero entry in the top left corner of your matrix. So swap rows if needed to put a non-zero entry there. And this is allowed, this is row operation 1 of swapping rows. If there's no non-zero entries in the entire first column, just move over 1 to column 2 and do the same thing there. Step 2 is to divide the entire top row by that first entry to make it be 1 in that spot. And this is operation E2, multiplying a row by a real number. We're dividing, but same thing as multiplying because that's how division and multiplication work. Now that we have this 1, I want to use this 1 to cancel out everything beneath it. This means I want to add multiples of the first row to every other row to make all of their first entries 0. And that is operation E3, adding multiples of one row to other rows. Now we've done all of this. We'll make more sense in an example, we'll do one in a second. But the idea is now this first column is entirely set. It's a 1 at top, it's all zeros beneath it. I can now ignore the first column and the first row for the rest of this problem. So I ignore the first row and the first column, and I step inside to now focus on the second row and second column as my starting point, and I repeat this process over and over again. So step 4 is that the first row and first column are now fixed. Leave them alone. You now want to reduce your problem to just ignoring those first row and first column and focus on what's ever left of the matrix. And repeat this process from there. Since you've already made all zeros in the first column besides that 1, your first non-zero entry will definitely be to the right of the ones before it. You can keep carrying out this process and it will automatically satisfy all of the properties you want for a row echelon form. Let's see this in an example and see what this might look like. So I want to solve the following system by reducing to row echelon form. So let's start by writing the augmented matrix for this system. 2, 3, minus 4, 1, 1, minus 4, 1, 4, 3, 5, minus 2, 3. Now I want to put this into row echelon form by using row reduction. So swapping rows, I could leave it just like this, but for convenience, because I see a 1 here, I'm going to swap rows 1 and 2. And this will give me a matrix 1, minus 4, 1, 4, 2, 3, minus 4, 1, 3, 5, minus 2, 3. Now I already have a 1 in the first slot, so I can skip step 2. And I want to add copies of row 1 to the other 2 rows to make these first entries go away. My goal is to make these 2 things 0. So what I'm going to do is I'm going to set row 2 to be row 2 minus 2 row 1, and row 3 to be row 3 minus 3 row 1. I picked those numbers because then in the first column, row 1 stays the same. If I take row 2 and subtract 2 copies of row 1, I'm subtracting 2 from that first entry, that puts a 0 here. The second spot will be 3 minus 2 times negative 4 is 11. The third spot will be minus 4 minus 2 times 1 is negative 6. And on the right side, I get 1 minus 2 times 4 is going to be a negative 7. For the third row, I get 3 minus 3 times 1 is 0. 5 minus 3 times negative 4 is 5 plus 12 or 17. For the third column, I get negative 2 minus 3 times 1 is negative 5. And I get 3 minus 3 times 4, which is negative 9. And now we can see we have our first column being 1, 0, 0, which is great. So what I'm going to do is I'm now going to ignore the first row and first column of this matrix, and now just sort of zoom in on the remaining part. I'm going to do the same process on the remaining part of this matrix. So if I want to get a 1 now in this first slot, there's no point in swapping rows at this point. I want to divide this entire row by 11. So I do R2 divided by 11. And note, because I have a 0 in the first spot, this does not affect my 1, 0, 0 in the first column. Because it's already a 0 there, it stays the same. This is why you always want to start from the top left and work progressively down the entire matrix, because that way when you set things up, you're not going to break it later on. So I still keep my 1, 0, 0 in the first column. I still keep my 1, minus 4, 1, 4 in the first row. Dividing the second row by 11 gets me a 1 in this first slot, a minus 6 over 11 in the second slot, and a minus 7 over 11 in the third slot. The third row stays the same. Now, to get rid of that 17, right, I want everything below this leading 1 to be a 0. I want to subtract 17 copies of row 2 from row 3. So I want to set row 3 equal to row 3 minus 17 row 2. Again, because these are both zeros here, they are not affected by this operation. So 1, 0, 0 stays the same. The top row stays the same. This row still stays the same. When I subtract 17 copies of row 2 from row 3, I get 17 minus 17 is 0 here. I will get negative 5 plus 17 times 6 over 11, because the minus signs will cancel. And I will see negative 9 plus 17 times 7 over 11. And yes, this is getting kind of nasty, but it is a process that will always work. We can then combine these expressions here, see what we get. To get us that sort of a setup there, I get a 47 over 11 in the first slot and a 20 over 11 on the right-hand side. And now, to finish this out, to get to actual row echelon form, I want to divide the last row by 47 over 11, because I want to get this leading entry to be a 1. As of now, I've got a 1 and 2 zeros, a 1 and a 0. I need to make this a 1 to then be in row echelon form. So if I do that, R3 times 11 over 47, I will get the top row is the same. The bottom row now becomes a 1 in this spot and a 20 over 47 in the last slot. And now from here, since we are now in row echelon form, I can find the solution. If I read off this last equation, this tells me that x3 equals 20 over 47. The second equation tells me that x2 minus 6 over 11 x3 equals negative 7 over 11, or that x2 equals negative 7 over 11 plus 6 over 11 times x3, but I know x3 already, so I can plug that in, which comes out to a minus 209 over 517, which simplifies to a 19 out of 47. And then finally, we have the first equation, which tells me that x1 minus 4x2 plus x3 equals 4, or x1 equals 4x2 minus x3 plus 4, but I know x2 and x3 already. I can just plug in 4 times 19 out of 47 with a negative sign, minus 20 over 47 plus 4, with a negative 76 out of 47 minus a 20 out of 47, and plus a 188 out of 47, which gives me a 92 out of 47. So that means my solution is my x vector, which I'll write as x1, x2, x3, is 92 out of 47, negative 19 over 47, and 20 over 47. And while that was long and tedious, that gave us an explicit algorithm and method for solving this equation. It's going to work no matter what the system looks like. You might have been able to get to it a little bit quicker if you would sort of play with the equations and figure out a better way to cancel things out. But in general, this method will always work and will always get us to an answer. As long as we approach it systematically, it's never going to break and never going to run into any problems. It will always get us to an answer for solving these system of equations using this row reduction method.